I think it's recording. Okay. I'm just gonna put myself aside. I swear I'm doing it. Oh, there we go. There I am. Uh, just doing this so you guys can, if I'm using my gestures to explain, you guys can just see my gestures too. Okay, let's get started with our topic test work solutions. Now, first thing first, when I'm looking at this question, it says f of x is 2 to the x, and it has been transformed to g to the x, where a bunch of this is happening. This is a lot of things at once, right? Let's have a look at it one step at a time. First thing first, the input was added by 2. This means it is left by 2 units. So that means whatever this initial exponential graph that would have looked like this has now been moved to over here. That doesn't really help in our situation right now, okay? And then what happens after is that it gets multiplied by -3. What happens if it gets multiplied by a negative number? It flips downwards and then it gets even bigger because of the -3, yeah? I actually don't care about the coordinates right now. And then what happens? It gets moved down by 4. So that means it goes down 4 again. The only possible option where it is represented like that is B. So we're done. Happy. Okay, let's move on. Question two. Oh my God, this looks terrifying. This is a trigonometric graph. I don't know how to solve this. Doesn't matter. What did the question ask for? How many solutions are there to the equation f of x equals to g of x? Well, it's these two graphs and equal. What does that mean? We're looking for the point of intersection. Points, actually, intersection. And more specifically, what am I looking for? How many? The number of them, number of points of intersections from negative pi to pi, which happens to be just perfectly the end point to the not to halfway through here. That was a trick question. Now I have this point of intersection and this point of intersection, but I'm not actually counting this. Mr. Scalone saying hi. And now I have two solutions. How good is that? Yeah, we'll move on. The function, this is dilated by a factor of half horizontally and reflected about the x-axis. What is the new equation of this function? This is a tricky one, unfortunately. If this is factor of half horizontally, this means everything halved, everything squeezed in. So whatever this function would have looked like, blah, 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 it gets squeezed in by a factor of half. What does that mean? It is a f of 2x. So horizontal dilation is actually the other way around from the factor that they tell you. And then it gets reflected about the x-axis. X-axis is the horizontal one, and if it's reflected around it, it goes vertical flip. So now that means it goes like this. It's a rotation. So now I need to put a negative into it. So all I need to do at this point is y equals 2. I put a negative in front, and then all of my x's just turn into 2 and 2x plus 1. And then, oh no, none of these look alike. What do I need to do? I need to somehow find a way to get rid of the negative and then put it in here. And I'm going to erase this because my word solutions will have everything included anyway. So it's the same as y equals to negative bracket 2x minus 1 all divided by 2x plus 1. This is the same as 1 minus 2x over 2x plus 1. Which one's that? I actually can't tell. Which one is it? Oh, wait a minute. That's not D. Oh, C. I can't read. Anyhow, the graph of this parabola, x squared plus x minus 12, is shown below. Boom. What values of x is blah, 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 a bunch of words greater than 0. I'm looking for the values where it's above the x-axis. Now, what does that mean? I need to find what these points are, and I'm looking for the x values that is on the right side and on the left side. How good. Well, I know as a matter of fact, the x-intercepts for these guys are like this. So that means x equals to -4 and 3. So that means x has to be less than -4 and x has to be greater than 3. How good is my life? What am I looking at? I'm looking for A. Okay, we move on. What a shame. Yeah, okay. A function, I'm sorry for giving you guys this one. It's the function f of x is obtained by performing the following operations on this fella that we have in the following order. It reflects in the y-axis. That means it's a horizontal flip like this. That means I do f of negative x, and then horizontal dilation by a factor of 4. Well, what did I say? If it's a horizontal dilation by a factor of 4, that means everything gets 4 times as wide. How do I make things wider? I need to divide the input by 4, right? So now I get f of negative x on 4. And then vertical translation 1 unit up. Thank God they were being nice to us after that. F of negative, oops, f of negative x on 4 plus 1. Let's chuck this in one at a time. I have square roots of negative x on 4 cubed plus 9 plus 1. Unfortunately, the plus 1 does not tell me anything because all 4 of these options have that. So, oh well, it is useless. Let's expand out and see what we can do. Negative x cubed, all divided by 4 cubed is 64, plus 9, plus 1. What is that? Oh, it's option D. Oh, good. We'll move on. Consider the graph of this guy with y-intercept of this guy. Which of the following is true? Unfortunately, this is a question where we actually have to find the values of B, K, and C for us to really see what's going on. You could do this in your head. That's fine. But I'm going to show you how I would like to just solve this, solve all of these polynomials, and then find the answer. First thing first, what do I notice? There is a horizontal translation to the right by 3. What does that mean? B equals to negative 3. So I have y equals to k over x minus 3, and then plus by a constant. What's the constant? Oh no, there's an elevation by 2. The horizontal asymptote went from 0 to 2. Like that. Okay. So now I know C is 2. Is that enough? We'll see. I need to use the coordinates x equals to 0 and y equals to 10 over 3 to find my final value of k. 10 over 3 equals to k over 0 minus 3 plus 2. That means it is 4 over 3 equals to k over negative 3, which is k is negative 4. So now what's that? C is the largest, B is the second largest, and K is the third largest. It is option A. It's always option A for these stupid questions. So annoying. Okay, the circle is transformed by vertical blah blah blah, translation 3 units down and horizontal translation 5 units right. What are the coordinates for the new center to transform circle? Well, what I do know is that this circle is not what desirable right now. This doesn't look like the one that we want, okay? So I want to make it look nicer. I'm going to move every constant term to the other side and start thinking in my head, oh, how could I make this a perfect square? And how could I make this look beautiful the way we want? I'm going to get the middle coefficient, divide it by 2 and square it. So I do plus 4. Same thing for the next one, y squared minus 6y. Divide negative 6 by 2 and then square it, it's plus 9. And then on this side, you need to do plus 4 and plus 9 as well. So now I have x plus, I use a different color, sorry. I have x plus 2 squared plus y minus 3 squared equals to 1. I don't care about the radius. Center right now is negative 2 and 3. That means the new center is just 3 units down, 5 units right, 3 and 0. All done. Let's move on. Consider the functions this guy and this guy, find the point of intersection for f of g and g of x, f of x and g of x, sorry. All we need to do is just equate the two fellas and you solve for 2 equals to 0. You get x equal x minus 3, x plus 1 equals to 0, x equals to negative 1 and 3. Happy times. 2 easy marks just like that. How good. Sketch the graphs of f of x and g of x on the same set of axes, showing all important features, including points of intersection. Okay. In order for me to do this, I need to find the points of intersection. Oh, sorry, important features and x-intercepts on their own first. So I need to do x squared minus x minus 2 equals to 0, x equals to 2 and negative 1. And x plus 1, well, hopefully we can just do that. X equals to negative 1. So we just do this. 1, negative 1, straight line. Definitely all me. I drew that. And negative 1 as well, but 2 here. So it looks something like this. I did not show all my important features yet because I didn't actually draw my y-intercept in for my quadratic. So negative 2. All done. Am I all done? No, I'm not. I need to actually do the point of intersection of 3. You're wrong. You're not getting full marks for this. The question said find the points of intersection. They didn't say the x values. You need to find the y values too. In this case, what I need to do is for x equals to 1, negative 1, sorry, we just choose whichever one of the functions we know and we like because we know either of them will work. G of negative 1 equals to negative 1 plus 1, which is 0. Happy times. Therefore, negative 1 and 0. And for x equals to 3, g of 3 equals to 3 plus 1, which is 4. Therefore, 3 and 4. 4, not to scale. Okay. Horrendous writing. That's okay. Now we've drawn everything in. How good. Hence, or otherwise, solve where g of x is less than f of x. Well, what does it mean? We're looking for the value where g of x, which is a linear, is less than the parabola. What does it mean? It means line is below parabola. When is that? All of these guys. Line is below the parabola here and here. Yeah? So that means when x is less than negative 1 and x is greater than 3. All is well. Okay. Now consider the function, this hyperbola. Find the x coordinates of the point of intersection of the function, this guy and this guy. Oh, thank God. The question said x coordinates of the points. I don't actually have to find the y. But why? Okay. Anyhow, 1 equals to x squared plus 6x plus 9. That means 0 equals to x squared plus 6x plus 8, which means x equals to negative 4 and x equals to negative 2. So once we have that, now we can move on. On the number plane below, sketch the graph of this guy and this guy. One unfortunate thing is that they didn't actually give us a chance to find the asymptotes and all that. We actually have to know this. First thing first, if I have y equals to 1 over x plus 3, there is no constant up or down. There is no plus c. There's only a plus 3. What does that mean? There is a left translation, x equals to negative 3, and everything else just looks like this, like a normal hyperbola that we expect it to be. Now, I need to find the y-intercept as well for this guy because we can see there's a y-intercept. So we say y int at x equals to 0, which means y equals to 1/3. Now, this one is hopefully not too bad. We have a graph that looks like this, and then boom. Whoa, not to scale, not to scale. Sorry. It should look something like that because it's a linear, and x-intercept should be a -3 and 3. Now, I have not yet drawn the points of intersections. -4. I think it was -2. Yeah, there we go. They didn't ask for the y value, so we didn't do it. Hence or otherwise, solve the inequality. This is greater or equal to the linear. How tricky is this? This is a very tricky one. Hyperbola is greater or equal to the linear. Where is that? I see that the red line is above the blue one here. That's good. And where else is this? Right over here. Right over here. It says greater or equal to, so we could include the points of intersections. That's fine. So now we say when x is less than or equal to -4, or when x is definitely less than or equal to -2, because we're including this point. But what do we realize here? When do we have to stop? At x equals to -3, we have to stop. And we actually can't include this point either. So we need to say -3 is definitely strictly less than x. It's a very important one here. Very important one. Very common mistake. You lose one whole mark because of this single mistake. Very unfortunate, right? Oh, I think my laptop battery's okay. It's surviving for now. Now, consider the function f of x equals to all that. Prove that this is an even function. So let's see. F of x is even if f of -x equals to f of x. Just a little peel paragraph. It's not going to kill you if you don't do it, but it would deduct marks if you don't do it sometimes, which is 8 over x squared plus 4. What is that? That is f of x. Therefore, even. It is very important. I always tell my kids this. If you don't write this statement and this statement and this connection, there's a reason why this is worth 2 marks. Okay, you're not going to get full 2 marks. All right. State the domain and range of f of x. Ooh, okay. Where does x not make sense? I saw many of you during the exam, when you guys are doing this, you guys said x cannot be plus or minus 2. But here's a problem. X squared plus 4 actually cannot equal to 0 for whatever reason, because x squared is always going to be a 0 or positive number. And if you add by 4, it will always be a positive number. It cannot equal to 0. So you say domain all real x. Now the range is when it gets a bit interesting. Because it's an even function, that means whatever happens on the graph, it's going to be symmetrical left and right, right? Yeah, whatever we can do. So I'm going to test kind of like all the big points. What happens if I say x equals to 0? It's going to be 2. What happens if x gets bigger, though? What happens as x gets bigger and bigger? It becomes a bigger denominator, right? So that means it becomes smaller, gets lower and lower and lower and lower and lower. It happens on the left side as well because it's even. Left and right are both going to be the same. It's just a bigger denominator. So it is actually just y could at most be 2, but it will always be greater than 0. I know some of your interval notation fanatics. So 0, comma, 2, rectangular bracket, y, epsilon. Okay, you guys can do that. That's fine. It's a beautiful thing. It's a beautiful thing. Hence or otherwise sketch the graph. Now, if you guys remember me showing you guys in class, I showed you guys the reciprocal way, drawing the x squared plus 4 and then reciprocating it. That you guys can choose to do that too. That's fine. It's like whatever you guys like. Again, it's not in the syllabus, so it's yeah, whatever. Anyhow, so let's see. State the domain and range of this function. X squared minus 1 cannot equal to 0. That means x cannot equal to plus minus 1. And range, if you think about this graph, it actually cannot be just one particular thing. It just can't be 0. Okay, so it's going to be one of the ways would be y equals to negative 1 over x squared minus 1. But there is no physical way possible for you to make anything so that the y value actually becomes 0. You can have 1 over a really big number, but that's just going to approach it. So y cannot equal to 0. So you can just say that. That's fine, okay? Show that f of x is an even function. It's a waste of time. You guys can do this. Yeah. Oh, I made the mistake. Putting the square on the wrong side. It's 1 over negative x squared, negative on the outside, x squared minus 1. Actually, by the way, when I was helping some of you guys out, I actually didn't see the negative. Jude and Bryn, I think, pointed it out for me. Thank you, guys. I gave some false information to some of you, therefore even. Now, find the equations of the vertical and horizontal asymptotes. What we just did is the equations. X equals to 2 and x equals, wait a minute, not 2, 1 and x equals to negative 1, and y equals to 0. That's the equation of the horizontal and vertical asymptotes. Straight line equations, that's fine. Now what do I have? Asymptotes at negative 1, and then horizontal asymptote is at 0. What do we know about horizontal asymptotes? They just will approach it. They can touch it sometimes. We don't know. We don't know what's going to happen. That's fine. So what did I say? We trial and error, right? We just say when x equals to 0, what is y? What is y? It is 1. So we know it's going to be somewhere around here. This is where I made a mistake. For those of you guys, I didn't see that was a negative. So yeah, I just said negative 1. My bad. I think Colin I gave that wrong information to Colin once. And now I just say, you know what? There's a negative 1 and 1. Let's just pick a point between 1 and, 0 and 1. Pick a half. Yeah. F of half becomes negative 1 over 1 quarter minus 1, which is negative 1 over negative 3 quarters, which is 4 and 5, 4 and 3, which is a little bit bigger. Let's try the negative one too. Wait a minute. What did we just prove though? It is even. So that means whatever I just did on this half is going to happen on the left side too. Boom. Boom. How good. Okay. Now at this point, I'm going to try on the value that is on the further right side or the left side. So what happens when x equals to 3? So now I have y equals to negative 1 over 9 minus 1, which is 1 over 8. So it's going to be somewhere around here. It's negative. You know what? Just assume it at this point. At this point, we know it's just going to be the same. Okay. It's always going to look something like this. It always is. It's going to be different signs wherever but it's always going to be something that approaches the asymptotes as we go. Okay. Now the graph of this guy is translated 4 units right and dilated vertically by a factor of half. That means it's squeezed. Which of the following gives the equation of the new function? Let's see. It is translated 4 units to the right, so it's minus. So you do y equals to 5 over x minus 4 plus 2. And then I dilate it by a vertical factor of half. That means it gets squeezed by 2. And that's option A. How good. Now, sketch the function, this guy. I have this tricky looking thing, and I have this linear. On the number pillar below, clearly label x and y intercepts. So let's see. This is just a quadratic parabola, but it just moved right. Is that right to you guys? I can't really tell. It's right, and then up by 2. Doesn't have to be to scale. I don't really care if it is not to scale. Actually, maybe, because our drawings will have to look something nice. Yep. And then we need to find the y-intercept, which is just 18. If the question didn't give you space to do a calculation, just do it in your head. See what happens when x equals to 0. Okay. Now, 13 minus 2x, it's going to be something like this. Yeah, this is definitely not to scale. I'm sorry. Let me just do it again. Should stop doing that. Oops. Something like this. Yep. 18 and 4 comma 2. And then now 13 minus 2x, it's going to be somewhere around here. 13, and then it goes down 2 at a time. So it's going to touch the x-axis around here. Again, not to scale. Why is it bent? Okay, so I have 13 on 2, something like that. Okay, now find the point of intersection of these guys, hence or otherwise using the graph above. Find the values of x that satisfy the inequality, this. They said point of intersection. Maybe there's only one. We'll find out if we sketch it out, right? So if we actually algebraically solve this, then it will make sense to us. 13 minus 2x. X squared plus minus 8x plus 18 equals to 13 minus 2x. X squared minus 6x plus 5 equals to 0. X minus 5, x minus 1 equals to 0. The question was stupid. It was grammatically incorrect. They should say points of intersection. X equals to 1 and 5. I can't be the one to talk about grammar because I suck at it, but well, it is what it is. So now what do we know? These are the points that it's going to meet, 1 and 5, not to scale again. So we're looking for the values where the parabola is less than the linear, which is strictly between 1 and 5. Therefore, x squared, x minus 4 squared plus 2, that's a weird minus, 13 minus 2x, when x is strictly between 1 and 5. Use interval notations if you want, that's fine. Is that it? Oh my God, this was a short test. Took you guys long enough? Jeez. I have to turn this off.